All right, so we just saw, or in the previous video, we looked at the logistic equation. Now, when I was doing that, I talked about a couple of tricks that I was going to employ to rearrange to get the general solution. And I said that if you're doing this for the first time, you might actually go down a different path and find an alternative version of the same solution. I'm going to look at that alternative form now, discuss a couple of points, and importantly clarify why we prefer the solution that we've seen. So this is a step in the solution, and this is where I started pulling little fancy tricks. You'll also remember the solution we found was the solution we found from earlier. That's a plus. All right. And we worked out what this A value has to be to satisfy our initial conditions, but we won't worry about that for now. So I'm just going to plug ahead and do this. So you might be tempted to clear the denominator. And then rearrange, group the P terms on the left-hand side. Like so. So then this is that's that. Now, this bears some similarity to our original solution, but it's not the same. We've got an e to the k instead of an e to the minus k, and we've got two of them, one sort of up and one down. So when students do this and they arrive at this answer, they're often quite confused. These solutions are effectively the same, and you can see that fairly quickly. If we multiply by this clever form of 1, right, that equals 1, right? If we multiply our solution by this, what we find okay, so very similar to our previous solution. I'll just rewrite it like this. And now you can see that it is identical to our previous solution, where we had to rewrite our constant of integration, but that doesn't matter because that's just a constant. We can do all sorts of naughty things to arbitrary constants. So that's our solution. We've recovered it. Why do we prefer this form of the solution to the solution that you might obtain just by clearing the denominator and everything. Well, I'll just rewrite it down here. The reason we like the form of this solution is because it only features one exponential. This one features two, and it's difficult to understand what happens in this as t tends to infinity. So as t tends to infinity, exponential e to the kt, that grows to infinity. 1 plus e to the kt also grows to infinity. But we can't figure out what happens to p because we've got this funny infinity over infinity form. We'd actually have to use L'Hopital's rule and battle to get a solution. On the other hand, this form of the solution, our preferred form, it's immediately obvious. The exponential term tends to 0 and we're left with k. So that's essentially why we like the form of the solution with the single negative exponential. It's more easy to understand in the limit. It's also easier to plot if you're trying to sketch curves of these things. But I think it's the obvious limiting behavior that means we favor this form of the solution over this form. Okay, so I hope that clarifies why I tried to obtain the form of the solution in the box. However, if you're working through it and you arrive at a perfectly legitimate solution that you're happy with and it's correct, that's all good. You might just have to work a bit harder to find out some limiting behavior and so on.